Hello everyone, thank you for joining me today at the VMUG here in Belgium. I'm going to be talking to you about understanding your data protection needs for your VMware Tanzu workloads. My name's Dean Lewis and I work here at VMware as a cloud management specialist. I also help out in our field, reporting back to our office of the CTO as well as one of their ambassadors. You can interact with us multiple ways today. So you can first find the details under this session and submit questions through Slido. You've also got a chat throughout today as well, and you'll see a little icon for that just under the video window. And then finally, you can get in touch with myself directly through my blog, theeducate.co.uk, and also via Twitter at SaintDLE. So I've got a handful of slides for you to go through over the next half an hour. So we're going to talk a little bit openly about, what are our data protection needs in our cloud native world. We're going to talk about VMware's Project Velero, our open source offering available to everyone. We'll talk about how we enhance that further using something like Tanzu Mission Control. And also we're going to touch on those third-party options. As you know, VMware has a huge ecosystem of vendors that can plug in and operates with all of our products as well. And when it comes to our cloud native offerings, that is still the same as well today. So why do we even need backup for cloud native? If we go back in time, I'm sure we all remember 4 or 5 years ago when cloud native started to be a thing and we were talking about Docker and containers, everything was ephemeral. We didn't need to protect that data, it was non-persistent. But as we start to see production use cases and mass adoption of Kubernetes and cloud native in our customers, we also know that maybe the initial ideas of cloud native weren't quite on the mark of how people would treat their data. So let's have a look at some of these areas. So we have a couple of different application styles, and we're going to break that down a little bit more over the next 3 slides. So we've got, of course, our stateless application. So that means we're not keeping any data. That is the true ephemeral side of using containers, which is fantastic. However, there's still configuration that backs that stateless application. So we need revision controls for those YAML files, whether that's in your source repositories where you commit to. Well, that's great. But also, how do you control some of that more pertinent information? If you're using ingress or load balancers, then you may want to keep those same IP addresses because of how they're used on your network through firewalls. And for example, if you redeployed that stateless application in the future. So actually, there may still be some needs to protect those configurations beyond what's available in your source control. You've then got your state stored in cloud services. So again, we go a little bit further with that. So revision control again for the configuration. We have to think about our backups and snapshots for those cloud services. And again, thinking about the scalability of that. Have you deployed into a cloud service such as AWS, Azure, or Google Cloud? And are you deploying that into the same availability zone, across availability zones, or maybe even looking at maybe something like a multi-cluster setup? We've then got our state stored in Kubernetes persistent volumes. So this is where we've actually got real persistent data that we are using inside of our containers, but we need to keep hold of, and maybe want to reuse that data outside of the Kubernetes environment, or maybe we need to share that between environments as well. So we need to understand how we can back up and replicate those resources and that persistent data inside of those persistent volumes. And then finally, we have the state stored in the Kubernetes API server or service itself. So we need to understand how we protect at a cluster level. Kubernetes is backed by etcd, which is the underlying data construct, which keeps controls of the whole configuration of your cluster, how you interact with it, the state of your cluster, and the operations going on as well. So very, very important areas. So all of a sudden, we've moved away from this idea of 5 years ago that our data would be ephemeral. We didn't really care. We weren't keeping anything in that environment, to actually now having a number of areas within our cluster that we do need to protect. So let's break that down a little bit more and think about some of our different types of deployments and how we orchestrate those deployments as well. So I wanted to focus a little bit on stateless applications and stateful applications. So in stateless, probably still going to be pulling some sort of data into those containers to work with. That data may be stored externally to the Kubernetes cluster, so it's not thought persistent within your cloud native environment. You're spinning up and destroying very quickly containers, and the container itself is ephemeral. And there's no particular configurations that you're interested in that environment. But again, there may be some considerations around networking that you still need to take into account. And it's very, very simple, as you can see here on the left-hand side of that diagram. For a stateful application, we're going to be keeping that container around. We're going to be keeping the data as well. It's in the name. So we may have certain areas that we're interested in, such as host names, whether it's inside of the cluster or external to the cluster as well. Security as well, so we might be using secrets, passwords, identities, maybe even pulling them from a third-party system. But most importantly, these stateful applications are writing to storage, and that will typically be inside of the Kubernetes cluster, or it may also write externally to the Kubernetes cluster as well. So we need to maybe understand how we deal with that and how we capture that as well. We can see here on the right-hand side of our diagram, that stateful service here is kind of a little bit more intrigued. And we've got things like maybe a gateway service as well, and that controls how we route to different pods from the outside world. And in this gateway service, we may have those pertinent host names and IP addresses that we need to keep hold of if we ever needed to restore that configuration as well. So we don't have to go back and reconfigure the rest of the network to deal with that change. So then let's break out into the full picture. So let's look at a full Kubernetes cluster. We've essentially got lots of copies of this diagram going on within our Kubernetes cluster. So we might have multiple applications backed by ingress or load balancers or both. So that's how do we contact that application from the outside network. We've got a number of services for our networking. How do pods communicate from one another? Is there any networking policies that affect them, whether that's at a namespace level or whether that's at a cluster-wide level? We then got more services which will back them individual pods, persistent volumes, backed by storage, whether that's vSphere storage, whether you're attaching storage directly to those Kubernetes clusters, especially if you're using it in Azure or AWS. And again, we may have these additional pieces of information which provide either configurations into our services when they're loaded, and even secrets so that they can connect to other systems or authenticate maybe even to databases, for example. Here, we've got a representation of a very simple application, a web front end, an application front end which runs in one set of pods, writes persistent volumes, and then another pod which runs our database service, which can store a lot of our data as well. So let's start diving into some of the options that we have available for data protection today. So first, I'm going to start talking about Velero. It's our open source data protection. It came across with us as part of the Heptio acquisition, and I believe the original name for it was Heptio Arc, and that's been renamed and given to the CNCF as an open source project under the name Velero. It's an open source tool to safely back up, recover, and migrate Kubernetes clusters and persistent volumes. It works both on-premises and in the public cloud, and it's built with Kubernetes in mind. So it was built for that cloud-native world. It's not an existing backup traditional provider that's then been re-architected to work with that. Three main components, that's the command line interface, the application itself, and volume plugins. And we're going to start to break some of that down in the next couple of slides. If you want to find out more information after today, you can go to velero.io for the full page. And we also have this available for the source code on our GitHub as well under VMware-Tanzu/Velero. It's the repository. So taking this from a high-level view in, the open source project itself backs up Kubernetes resources to some sort of object storage that are S3 compliant, Google Cloud, or Azure, and of course, AWS S3 from that compliance point of view. It has the ability to provide snapshots and backup persistent volumes in your Kubernetes cluster. We have support for Kubernetes running anywhere, including on top of vSphere, AWS, Google Cloud, Azure, so those native Kubernetes offerings within those clouds, but also Tanzu running across your private data center or those public clouds as well. Of course, we've already touched on that part of the Tanzu project. Integrated today with Tanzu Mission Control, which we'll talk about in a later slide. and it's integrated into products such as Dell EMC Power Protect as well. From a capabilities point of view, we can back up all cluster resources, individual namespaces, or selections of resources by label. We can back up that persistent volume data, and we do that via either Restic, another open source application, or a third-party Snapshot plugin, and we'll talk a little bit more about that in detail. We can use execution hooks for QSing applications and other operations, so let your applications know that it's being protected. We can, of course, schedule backups like you'd imagine or expect from any backup product out there. We've got control via command line. You can also write custom resource definitions so that you can call this through kubectl when interacting with your Kubernetes cluster directly. And you've got the ability to restore to new clusters and namespaces or into existing clusters and namespaces as well. So let's dive into that architecture. So in the middle here in purple, we've got our Kubernetes cluster. We're going to deploy Velero itself directly in as an application. So it's going to run in its own namespace, its own pod, and that runs the Velero services. So the Velero server itself. We're going to run the Velero plugins, the Snapshot plugins, which we'll talk about. We also then can create Velero custom resource definitions inside that Kubernetes cluster, and we can interact with them either using the Velero CLI or the kubectl CLI tool as well. We will also create separate custom resources for the volume backups. And again, to protect those volume backups, we're either going to be using the Restic application to do that, or we're going to be using that plugin as well if it's for CSI. And then essentially the server is going to orchestrate moving that data that we've protected into that object store, which sits outside of our Kubernetes cluster to give us that out of world protection of data. So this Restic thing that I've been talking about versus Snapshot plugins for protecting our persistent volume data, because that's what we're really interested about today. Where does this come into place? How do we deal with that? So we use Restic today because it's system and storage agnostic. It doesn't have a snapshotting capability for your applications. So you may have to build in how you tell your applications they're being protected and that data on that volume is being protected so that it can be quiesced, or the file system is frozen. So you can create execution hooks within Velero to handle that for you. It does work with file systems as well, but it does have to search for changes within those file systems. The volume snapshot plugin works in a slightly different way because this is used to interface with the storage system to take snapshots using the cloud native storage interface, which is a plugin that moves away from in-tree drivers where storage connectivity was baked into your version and deployment of Kubernetes. And the volume snapshot essentially is going to talk to that new CSI driver. And CSI drivers are going to be the new way forward from Kubernetes, and they're going to phase out in-tree drivers in the future as well. So we're expecting to see an increase of use of volume snapshots and maybe a possible move away from Restic in the future. It does have the ability to give you crash consistent on a per volume basis for those applications. And you can back up of the data internal to the plugin, that storage system. And because it's using the CSI driver, it's typically going to be block orientated, but in the future, there's also support for file orientated as well. Okay, so taking that one step further, so how does this fit into vSphere and vSphere with Tanzu? We do have a volume snapshot plugin for Velero, which we've just talked about. It also then has the ability to plug into vSphere itself. So this is going to handle snapshotting and backup of restart of vSphere persistent volumes. This is where Tanzu is talking to the vSphere layer, using the CSI driver for vSphere. It will back up that full persistent volume. Unfortunately, today, it does only handle full backups of that volume. So it's going to take a full copy of that each and every time to move it. It will scale out data movers as it needs, as it's protecting the data in your environment. And in our versions here, we've essentially two major milestones today. So our first major milestone was 1.0.2, which handles backup and restore vanilla Kubernetes on vSphere, so that was bring your own Kubernetes environment. From 1.1.0, of course, we made that big push for Project Pacific, which is now vSphere with Tanzu. So that's having Tanzu Kubernetes Grid native inside of your vSphere cluster. And we can handle the backup and restore for vanilla Kubernetes clusters, those guest clusters controlled by workload management inside of vSphere, and also those user workloads inside of the supervisor cluster as well. So we've really enhanced those features for your different offerings from VMware for your Kubernetes environments. And how does that architecture work? So Velero will initiate the backup. The vSphere plugin is called to snapshot that persistent volume because the persistent data is going to be stored in the vSphere storage itself. So that's available to all of your ESXi hosts. So the snapshot is created by vSphere for that first class disk. Velero is going to then persist the metadata and the snapshot ID to S3. So that's the configuration and the understanding of that persistent volume being used inside of the Kubernetes cluster itself. The data manager is then going to move the data from the vSphere world, from that VMFS volume, from that vSAN volume, from that vVols volume to your S3 environment. And then it's going to remove that local snapshot from the vSphere world for you. So that's some of the enhancements that you can expect to see if you're using this in a vSphere-based world, rather than maybe consuming Velero with a Kubernetes environment running in AWS. Moving on, so the vSphere architecture plugin architecture for the 1.1 becomes more in-depth, and that's because we support the supervisor clusters and guest clusters for that native integration with Tanzu within vSphere. And that brings some challenges because of the way that you access and consume storage through the supervisor services into your guest clusters as well. So again, Velero is going to initiate that backup in your guest cluster. The vSphere plugin is going to be called for that snapshot of the persistent volume, that first class disk inside the vSphere storage. The plugin is going to write to the backup driver custom resource inside of the guest cluster. And that guest cluster is going to proxy through to the supervisor cluster because a guest cluster does not have access to the vSphere environment where that persistent data is stored. That's part of the security and RBOT model that's set up with using vSphere with Tanzu. So the supervisor cluster is going to handle taking that first class disk snapshot through its through the CNS. Velero then is going to kind of do the same things that we expected before. So it's going to persist that metadata and snapshot ID to S3. The data manager is going to move all of the data to S3, and then the local snapshots are going to be removed. So we can see here, it's a lot more in depth than the previous screen because we have to deal with the architecture of vSphere with Tanzu. Okay, so that's what's available today in the open source product itself from VMware. There's quite a lot of functionality there. Excuse me. But you have to go off and deploy that into each of your clusters and kind of manage it yourself. From VMware, we also give you the ability to consume Project Velero as a data protection feature through Tanzu Mission Control. And that's where I'm going to show you one of the small areas today. So a little bit about Tanzu Mission Control itself. So Tanzu Mission Control offers fleet holistic management across your cloud-native platforms. It's a SaaS offering which gives you visibility and policy management of your Kubernetes platforms. It provides you also the ability to deploy and lifecycle Tanzu Kubernetes Grid environments into AWS, vSphere on-premise, VMware Cloud and AWS, and in the future, there is more platforms coming in the horizon. So previously, we talked about using Velero, but if we had multiple Kubernetes clusters, we'd have to go off and we'd have to then set up our Velero and each cluster, create our own schedules, interact with it at a command line, and it can kind of get a little bit messy when you're using it at scale. And maybe also as well, you want to maybe centralize the control and the RBAC and access to your backup department. That are running and creating these schedules for you as well. So how do you do that at scale? So this is where Tanzu Mission Control comes in. We bring everything that we've been doing with Velero into Tanzu Mission Control itself to provide you the centralized data protection management so that you can provide backup and restore schedules, provide all the activity details. You get a single point of control, either through the user interface, the command line interface, or API. It provides the lifecycle management of the versions of Velero that's pushed into your clusters. It can be provisioned into AWS for S3 storage through the through the Tanzu Mission Control, or you can bring your own storage options as well and still configure Velero to push to a local S3 object store if you so wanted. And again, you still have the ability to use the Velero CLI for these use cases as well. So if you're managing it centrally through Tanzu Mission Control, users can still go off and use the Velero CLI as well. Okay, so we obviously talked about what VMware brings to the table, but we also have third-party offerings available as well. So I'm going to talk to you about two alternative options, but there are more out there as well. As I mentioned, we already today know that Velero is used as part of the Dell EMC Power Protect environment. So one of the ones that I want to kind of quickly cover on is Kasten by Veeam and their K10 architecture. So Kasten offers you the ability today to protect virtual and physical cloud-native infrastructure. They offer the Orchestrator APIs and management to do this. And if I just build out this slide somewhat, they have the underlying Orchestrator platform itself, which is the K10 platform. That's going to set up your policies and protection schedules and lifecycle operations for protecting that data. It then offers infrastructure APIs, so it can interact with your block storage providers and your object and file storage providers for one, protecting your data, but also two, of where to target your data from saving as well. And then three, it has an application framework on top, which then has the ability for agentless hooks into your applications so that you can provide that application-aware protection as well. Next, I want to talk to you a little bit about Portworx. So Portworx have a tool available called PX Backup as part of their Portworx suite. And again, very similar to what we talked about with Project Velero and also Kasten. It focuses on application backups, has namespace awareness, support for multi-cluster and multi-cloud environments. You can import cloud volumes not managed by Portworx today. So Portworx, one of their strong points is a scale-out storage architecture across clusters, and also provide you easy assets and backup governance as well. And we can see a little bit here. If it's understanding Kubernetes cluster, various applications, PX Backup running there as well, and then moving out to Object Store. One of the things I will say today, if you're using Portworx inside of vSphere with Tanzu today, because our CNS driver doesn't natively support snapshots, Portworx needs their storage layer to be in place so that it can provide that full snapshot capability for data protection, whereas Kasten will call off to the vCenter APIs to protect that first-class disk. So again, there's kind of maybe some nuances in how they work today as well. And then, as I've mentioned, there are other third-party solutions available. So Dell Power Protect, Veritas, and a number of other solutions as well. I really just wanted to kind of touch on some of the ones that I personally worked with and some of the ones that we've also started to validate through our ISV program for Tanzu as well. So I've covered off a number of slides today. So I am going to now move into my web browser, and we're going to look at two of these options as well. So first, we're going to look at Tanzu Mission Control, and then second, we're going to look at Kasten as well in an environment. So I'm just going to stop my share and move over to my screen. Okay, so this is Tanzu Mission Control. As I mentioned, Tanzu Mission Control is fleet management for Kubernetes clusters across environments. See here in my environment, I've got OpenShift, I've got Tanzu on vSphere, and I've got Tanzu in AWS as well. So I'm not just limited to things with the word Tanzu in front of it. So the first thing I'm going to do is I'm going to click into one of my clusters here. So I'm going to click into this Workload 2 cluster. And we can see we've got the ability to set up a number of integrations. So I'm monitoring my cluster. I can see the number of nodes, the namespaces, the workloads. I can set up RBAC and policies against that, but obviously I'm not going to kind of cover that in depth today. What I am going to do is scroll down in this cluster to this data protection feature, and it's very, very simple. I'm just going to click Enable Data Protection. It's going to install Velero, and I can obviously go off to the documents to find out more information about that. I'm going to click Enable, and it can take several minutes to do that. So for today's live demo, here in the UK, we have something called Blue Peter, and we call it a Blue Peter moment when we have one that we've prepared earlier. So I'm going to move into my workload cluster 01, where I already have data protection available. See here that we've got create a backup, and I can do that from the screen. But I also now have this additional tab called data protection. So I enabled that earlier today. And we're just going to go through, and really you're going to see some of the options that are available, but also kind of see that this isn't any different to what you'd expect from a normal backup environment. So I've got the option to back up an entire cluster, selected namespaces or resource labels. So I'm going to select namespace for today. I'm going to back up my CPU example namespace. You can also see any labels and anything that's been pulled through that we're interested in. I'm going to click next. My target location. So this has been filled out for me already. So where to send the backup file. So I've already configured this in Tanzu Mission Control, and I can show you that in a second. What type of schedule? And again, the schedule is exactly how you'd expect it. If you go to custom, then we use cron expressions for these schedules. How long do I want to retain this for in my AWS environment? So we're going to do it 2 days, then give it a name, and we're going to call this VMware demo. If I, that's lowercase, of course, because it's a Kubernetes resource. So it's strict on that. But we can see there, it tells me straight away what that problem might be. Not available for backup. So that is where demos fail today. So under this organization, okay, let's try. Here's one I might have made earlier. Let's enable that. So I do know what the problem is in this cluster. I was playing around with the networking and trying to break something as a test, and it thinks like I must have successfully done that, and now it doesn't work. So not to worry. Got a couple of minutes left of today's session, so I'm going to move into Kasten, and hopefully we'll come back to this in my other clusters enabled for AWS. Shouldn't take too long. But as you can see, this is a live demo, not a pre-recorded one. So I'm going to move into Kasten now. So this is Kasten environment that we've set up as a demo. So Kasten gives us a nice UI. It's obviously focused on data management centric. If I go to cluster settings, we have this idea here of location profile. So we can send this to other systems outside of our Kubernetes clusters. We've got our infrastructure profile. So here we connect this to vSphere in our environment so that it can protect our vSphere-based objects. So they're first-class disks where we don't have the native snapshot capabilities. And then we can see all of our applications that are available in the cluster that we're connected to as well. So we can see here we've got a Pacman application. And if I go back to the dashboard, we've also got these policies. So if I create a new policy in Kasten, again, it's very similar to any other environment that we've used before. What type of snapshot do we want? What frequency? Do we want to export that to our location? So Azure or an S3 bucket, for example. How do we want to select these particular applications? So again, we'll do it by namespace. We're going to select Pacman there. What type of resources? And then I create a policy as well, and that creates it for me. And I've got the ability then to run this if it's not already running on a test as well. If I go back to my clusters and look at this from the application view, so this is on the multi-cluster dashboard. So if I go back to my normal dashboard, I can go to applications. I can see Pacman. We can see it's non-compliant today because we were playing around this environment as well. As you can see, I wasn't probably fully prepared for this. But if I click on restore here, I've then got the ability to see my different restores that are available and where I send that to as well. And then I can see all of my different objects. So quickly, just going to see in my Tanzu mission control, we've got my ability now here to create a backup. We go through this. We'll quickly go through all of this. Give that a name. And now we can see that this backup's taking place on my Tanzu mission control screen. And then once this is completed, I could highlight this and I've got the ability to restore it. Okay, so I think that brings me to the end of today's session. Thank you very much for joining me today. I really appreciate it. Apologies for the demo hiccup there. There's a number of resources on screen for you today. Essentially, Velero.io, Tanzu mission control, product pages, the custom product pages, the Portworx product pages, and any third-party vendor that you're interested in today. And thank you very much for your time.